Hi, my name's Thomas Mcauley. I'm second officer here on board the Pride of Hull and I work for P&O Ferries. My responsibilities here on the Pride of Hull are a navigation officer, and in that role I drive the ship from point A to point B, and also I'm responsible for the loading of the cargo down on the vehicle decks. Maths is a really important part of my job here on the bridge, particularly in terms of navigation. We use it on a daily basis. As a result of that, you have to have a minimum grade of C at least at GCSE level in order to gain entry into the apprenticeship. Some companies, however, require A-level maths, and there are even instances of people entering into the apprenticeship with degree level maths. Whenever a ship goes from one port to another, it's very important that we have what's called a passage plan. And a passage plan is like when you get in your car and you plan a route to go from one point to another point, except it's on a ship. To do this, we use what we call charts, which is like maps of the sea, and we draw our course lines on the charts to get safely to the next port. Once the captain's approved that passage plan, we can then execute it and set off out to sea. Okay, one of the ways that I can monitor the passage plan is to use the following technique, which is a way that I can calculate the distance of the vessel off a fixed object, such as a platform or an oil rig. Okay, this line here represents our course line, or our passage plan, as I explained earlier. The ship would have set sail about 3 hours ago and is now sailing on a course of due north, or as we would say, 000 degrees true. Now, things affect the ship as it's at sea, most notably the wind and also the tide and the current. And so, in actual fact, the ship may not be directly on the course line, it may have drifted off. It could be over here, or it could be over here. So in order to check that the vessel is actually on course, I'm going to measure the distance off a fixed object, which in this case is an oil rig, which I'm going to draw on here. So to do this, I first of all set my compass binnacle up on the bridge wing at an angle of 45 degrees. And as the vessel tracks along, I would wait until the oil rig came into view, like this. And then I would take a bearing of the oil rig and note the time. This point here is then point A. Once I've done this, I'll then reset my compass binnacle and put it to 90 degrees off my course line. So the vessel will be tracking up from this point to this point. I would then note the time again and mark this point on my line as point B. So we know that this angle here is 45 degrees. And we also know that this angle here is 90 degrees. This angle here is therefore also 45 degrees, because we know that the angles in a triangle add up to 180 degrees. So this angle here is also 45 degrees, and we therefore know that this triangle is actually therefore an isosceles triangle. Because we measured the time between point A and point B, and we know that our ship's speed is roughly 20 knots, we can actually calculate this distance AB using the formula distance equals speed times time. Because this is an isosceles triangle, we can therefore deduce that distance BC is also equal to distance AB. Therefore, we know the exact distance off the oil rig and how far off the course line, if anything, we are.